rational functions today. So it is a longer process a little bit, but I will give you literally step-by-step instructions that you follow. And if you do those, it's really not bad. So a rational function, obviously in this unit, if you haven't noticed, we're dealing with polynomials, graphing, and functions kind of in general. So rational functions mean fractional functions. So if we have a polynomial p of x divided by a polynomial q of x, we know that q of x cannot be 0 because we can't divide by 0. And we know that based on rational functions in the past, we know our domain will be all real numbers except for what would make the denominator 0, right? So in this one, right here's a rational function. We would say x cannot be 2, therefore the domain would be negative infinity up to 2, and then union 2 to infinity. So remember, I've been saying throughout the year, we go from negative infinity, we get to 2, we jump over 2 and go to infinity. You're going to see that happen today because we're going to be graphing this, and what it's jumping over is a vertical asymptote. So with this one, our restrictions are x cannot be 0, negative 2, and 3. So we would have asymptotes at 0, negative 2, and 3. So I could write down the domain connecting through negative infinity up to negative 2. It would jump over negative 2, union. Then it would go from negative 2 up to 0. It would jump over 0. Then it would go from 0 up to 3. It would jump over 3. Then it would go from 3 to infinity. So notice I just connected all the way through, you know, no big deal. Connected all the way through here. So, yeah. Our domain is going to be a little bit more straightforward. Okay, let's just start out by graphing the most basic rational function, 1 over x. So without even graphing it, we already know how to find this as domain. We know that x cannot be 0. So then wouldn't our domain be negative infinity up to 0, union 0 to infinity? We know that without even graphing it based on all the practice we've had this year. Okay, let's look at graphing. Now let's say, because we don't know how to graph these, we don't know the step-by-step instructions yet, let's just plot some points and kind of see what this graph's doing. So if you think about it, I'm just plotting some points. If I plug in negative 3, I get negative a third. If I plug in negative 2, I get negative 0.5, right, everyone? If I plug in negative 1, I get negative 1. If I plug in 0, I get undefined, because you can't plug in 0. We just stated that. If I plug in 1, I get 1. If I plug in 2, I get 0.5. If I plug in 3, I get 1/3. Now, plotting points is usually easier with decimals, so don't be afraid to use decimals today, okay? So watch me kind of graph this, and then we'll kind of see if we can piece together what's happening. So I'm going over negative 3, down a third amount, or whatever. Over negative 2, down halfway. Over negative 1, down 1. And that's all I have. We're then skipping over 0, right? Jumping over 0, and then we're going over 1 up 1, over 2 up a half, over 3 up a third. Now, we all understand that I've only plotted a couple points. There are an infinite number of points I could plug in. If I keep plugging in negative 4, negative 5, won't it just be getting smaller and smaller? So as it's coming up right here, it's just getting smaller and smaller, and it's actually approaching 0. Now think about it. No matter what I plug in, will it ever actually be 0? No, like it'll just be a smaller and smaller number, but it will be, the bigger we plug in, the smaller and smaller, the closer and closer to 0 it gets. Okay, so that's actually creating a horizontal asymptote, as we'll see. Now from here, if we look on this side, if we go further to the right here, if I keep plugging in stuff, isn't it also just getting closer and closer to 0? So it's coming down and getting really, really small, close to 0. And once again, if you think about it, whatever I plug in, no matter what I plug in, it will never be 0. Now, guys, the graph doesn't actually just stop here. We have an asymptote. We said x cannot be 0, so we know our domain is connecting through. It's creating a vertical asymptote at 0. So right here, x equals 0 is a vertical asymptote. So first fun fact for you, vertical asymptotes come from what makes the denominator 0. Now here's the thing, our graph, if you think about it, you guys, we don't only have whole number of points. Isn't it also true that I have an infinite number of points in here? Right? Like I could plug in as many points in here as I wanted. So I have a bunch of decimals that I haven't plotted. So there are still parts to the graph here. It doesn't stop. But what's happening? It's coming up and it's approaching this asymptote, but it is not crossing it. And then same here, it's coming up and it's approaching the asymptote, but it's not crossing it. So now if you look from left to right, it's connecting through. Our domain's making sense. Look, negative infinity, it comes here, then it's just hugging the asymptote. Then it jumps over it, and it's hugging it, and then goes to infinity. Now technically, because as we saw here, as we plugged in values, smaller and smaller and larger, it was approaching 0. We actually have a horizontal asymptote as well at y equals 0. So we have two asymptotes here, vertical and horizontal, and that will always be true for rational functions. We will get into more detail of where these come from in just a second. Okay, I first of all just want to make sure that you're able to kind of read a graph. Okay, so this says, as x is approaching infinity, what are your y values approaching? What values are your y values getting closer and closer to? So look, as I go this way, as I go to infinity, what value is your function approaching? It's approaching 0, guys. So as we go further out, isn't this getting closer and closer to 0? So then as x goes to negative infinity, what value is your function getting closer and closer to? 0 again. Now if we read this, this reads, as x approaches 0 from above, that just means in the positive direction. So here's 0, guys. Here's x equals 0. As we approach x equals 0 here, as we get closer and closer to 0, where is your function approaching? Infinity. You guys see how as we get closer and closer to 0, it goes up and closer to infinity. It's growing to infinity. And then this says as x approaches 0 from below, so here's 0 from below, as x approaches 0 from below, where's your function approaching? Negative infinity. Now that's not super important. I just wanted to make sure that if you were to see a graph that hopefully if they did ask you this on the test, you'd be able to answer it. So let's get into more detail of where our vertical and horizontal asymptotes come from. And then we're going to make sense of it so that we actually, it's a little bit easier to memorize. So here it is. Maybe, once it thinks for a second. Okay, so we're going to first focus in on vertical and horizontal asymptotes because really, that's the first thing we do when graphing, is we graph our vertical asymptotes and horizontal asymptotes. So everybody, vertical asymptotes come from what make the denominator 0. We can't be 0, therefore a vertical asymptote is created, preventing our graph from ever crossing that point. Or it's going to approach that value but not cross it. So this vertical asymptote always comes from what makes the denominator 0. Now there can be more than one vertical asymptote. And we know no matter what, it's going to come and approach it somehow. It's going to approach it, but it will not cross. It cannot cross a vertical asymptote. We know for a fact it is true that we can never, ever, ever divide by 0. This is a big no. So any questions on vertical asymptotes, where they come from? So right here I obviously put, if we have ax plus b divided by cx plus d, I set this equal to 0, I subtracted d divided by c, this would be our vertical asymptote because that's where I set it equal to 0 and solve. That's what would make the denominator 0. So now horizontal asymptotes, everybody needs to understand, a horizontal asymptote is way different than a vertical asymptote. Horizon, these are horizontal asymptotes. Now what this does is it tells us where our function is approaching on the horizon, on the far left and the far right of our graph. That's really important to understand. So it's what's happening, Claire, at the far ends of the graph, where your graph is approaching. They're called end behavioral asymptotes. Now there are actually 3 rules we're going to learn where different things will happen depending on what we're seeing. Here's what you focus on. You always focus on the leading term. And that will tell you everything you need to know about a horizontal asymptote, which we're going to get into in the next slide. So right here I gave just one of the cases. If we have the same degree, which I'll have this in a second, I'll have this in more information in the next slide. If we have the same degree on top and bottom, you would just divide out your leading coefficients, and that would be your horizontal asymptote. So we would have a horizontal asymptote if this was the case, degree 1 divided by degree 1. A divided by C. Your leading coefficients will be on the horizon where your function approaches. We'll talk about why in just a second. So based on this, really, if we look at this, just let's test your abilities here. What would be my vertical asymptote? 1/4. X equals 1/4. Vertical asymptotes come from what makes the denominator 0. Now, one more thing I do want to say, guys, is because this is a horizontal asymptote, it can cross horizontal asymptotes. Now, because it's just telling us what's happening clear on the far end of our graph. So let's pretend we had a graph that was coming in and it was approaching this asymptote, and then eventually it crossed it. That can happen, but it will still hug it. It might cross it, but it will just still then hug it right underneath it. It will never stray away from it. So just understand, vertical asymptotes cannot be crossed. Horizontal can, because horizontal only tell us where our function's approaching on our end behavior. So don't fret if you see it cross a horizontal asymptote. It might cross it, it might not. Okay, and so in this one, based on that one example, that's only one case. Do you guys see how they have the same degree on top and bottom? Then our horizontal asymptote would be our leading coefficients divided, so that'd be 2 divided by 4, which is 1/2. On the horizon, it's going to approach 1/2 on both ends. So our horizontal asymptote would be at 1/2. So let's get into more detail, because that's only one of the cases. Let's get into the 3 different cases you're going to see with horizontal asymptotes and behavioral asymptotes. All right, so we're gonna just, so yellow, orange, green, 3 different rules. Start writing down yellow, and then we all really do need to try to actually make sense of why it is what it is. In Sec 3, we allow you to just memorize the rules. We don't talk about why. In here, you have to be able to really understand why. And I know I can explain it hopefully to a point where you can hopefully understand it. Okay. So once again, vertical asymptotes always come from denominator being 0. But horizontal asymptotes have 3 different cases we're going to see. So we're talking on the horizon and behavioral asymptotes. So the first rule is, if your leading term has the same degree, that was what I showed you in the last slide. If the leading term has the same degree, the degree, right? Degree 2, we're talking degree here. If it has the same degree, then all you have to do is divide the leading coefficients, and that will be your horizontal asymptote. So for example, right here, notice the highest degree is 2 on top and 2 on bottom. Therefore, my horizontal asymptote would be at the leading coefficients, so 2/3. I haven't explained why yet. I'm just making sure we understand the rule before I explain it. So right here, if you look at it, technically it's easier to look at things in standard form for horizontal asymptotes. Now I only need the leading term, so notice x times x on top. If I was to distribute this, would be x squared, agreed? On bottom, x times x would be x squared. Do you see how the degree on top and bottom are the same? So you would divide your leading coefficients. 1 divided by 1 is 1. So this one would have a horizontal asymptote at y equals 1. Okay, looking at this one, the degree 3 on top and degree 3 on bottom means that we'll have a horizontal asymptote at the leading coefficients. -4 divided by 2 is -2. We would have a horizontal asymptote at -2. Okay, now before you start writing down the next rules, let's try to understand and grasp why this might be. Okay, so is everybody ready to kind of listen to maybe why? Okay, so here's what you have to understand. We're talking what's happening clear out here on the horizon, where it's approaching on the horizon. Like, we can plug in big and bigger and bigger and bigger and bigger numbers, and it's going to approach that value. So why? Now let's think about plugging in. Everybody grab a calculator. If I was to plug in a 50, even just a 50, everybody, that's not even that big of a number, right? So let's plug in right here. I want you to, everybody plug in into this, plug in 50, and tell me what decimal you get. So you'll do 2 times 50 squared plus 3 times 50, then hit enter, and then divide it by 3 times 50 squared minus 2 times 50, and then just tell me what decimal you get. So we get 0.69, right? Now 50 is not even big. Now look guys, we said it was going to approach 2/3, right? 2 divided by 3 is 0.66. You guys see how they're so dang close? So if you think about it, 50 wasn't even big. Well, if you plug into 1,000 now, it's going to be even closer to 0.66. Do you guys see how it's just getting closer and closer? Think about plugging in 1,000,000. It's going to be so dang close to 0.66 that it's like pretty much 0.66. Does that make sense? So it's n behavioral asymptotes. So here's what really matters, guys. Right here we have 2x squared and plus 3x. This plus 3x is not really going to affect anything. If you think about it, if I plug in 1,000, 2 times 1,000 squared plus 3 times 1,000. 1,000 squared, guys, is 1,000 times 1,000. That is a huge number. Way bigger than 3 times 1,000, right? So if you think about it, this little piece isn't really going to matter in the calculations. It is going to make a teeny tiny bit of difference, a teeny tiny bit, but really not that much of a difference. What's going to matter is the leading term. So right here, if I plug in 3 times 1,000 squared, once again, this isn't really going to matter much in my calculations. Yes, it's going to affect it, but barely any. So really what matters is our leading terms. Well, if that's true, then what's 1,000 squared divided by 1,000 squared? 1. What would that leave me with? 2/3. No, not necessarily exactly 2/3, right, because of this, but it's close to 2/3. Does that make sense, everybody? It's dividing out perfectly, that huge number. Approaching that value. So hopefully that kind of makes sense to everybody. Okay, let's go on to rule number 2. If the degree on top is smaller than the degree on bottom, it will always approach 0. Our horizontal asymptote will always be 0 no matter what. So the degree on top is smaller than the degree on bottom, it'll always approach 0. So look, degree on top is smaller than the degree on bottom. Degree x to the 0 is smaller than degree x to the first, so this will have a horizontal asymptote at y equals 0. Right here, degree 1 is smaller than degree 2. Degree on top is smaller than degree on bottom, so it'll always approach 0. Degree on top squared is smaller than the degree on bottom, so it'll approach 0 on the horizon. Now notice, and a lot of times people will see this and they won't think, and they'll say, oh, well, they're the same. Nope, they're sure not. If we have it in standard form is the easiest way to look at it. So on top we have an x, and on bottom we technically have x squared. The degree on top is smaller than the degree on bottom. It's going to approach 0. So hopefully we have that rule written down. Now let's think about now y once again. Okay, so just like up here when we were plugging in 1,000, 1,000 is not even a big number, you guys. So let's just start with 1,000. If I plug in 1,000 right here, what's 2 divided by 1,000? The minus 4 is not going to really matter much. Yes, 1,000 minus 4, but you see 1,000 is pretty much 1,000. 1,000 minus 4. What's 2 cut up into 1,000 pieces? 0.002. Almost 0. Agreed? Well, 1,000 is not even a big number. Plug in 1,000,000. 2 divided into 1,000,000 pieces is pretty much 0. Do you guys agree? So what's happening is it's literally like approaching 0. So look right here. If I plug in 1,000 here, we have 3 times 1,000, which the 3 is not going to matter much here. We have 1,000 divided by 1,000 squared. 1,000 squared is 1,000 times 1,000. So if you have 1,000 divided by 1,000 squared, it's going to approach 0 because it's just going to be cut up into such small pieces. So yeah, people say, but it's not necessarily, it's not 0 though. I'm like, you're right, it's approaching 0. That's the definition of an asymptote. Does that make sense to everybody somewhat? Okay. So then, rule number 3 is if the degree on top is actually larger than the degree on bottom, we're actually not going to have a horizontal asymptote anymore. What's going to happen is we're going to have a slanted, an oblique, they call it an oblique asymptote, a slanted asymptote. And we're going to see why that happens in just a second. So we're only going to really, in this class, be dealing with linear asymptotes, oblique asymptotes, but there could be any type of asymptote, any number of asymptotes. So if you look at this right here, if we have x squared minus 4x minus 5 divided by x minus 3 here, if we were to just divide our leading terms, what's x squared divided by x? X. Do you guys see how we're getting linear something? X. I haven't gone through and actually done the division, which I'll need to if we're actually doing it. But I'm just trying to get you to see that we would have a linear, a slanted asymptote if we did go through and divide it out. So you'll see us do that in a couple examples. So if the degree on top is larger than the degree on bottom, they do divide. So in this one, we're going to have what type of asymptote? Degree 3 divided by degree 1. A squared. Now guys, we can graph lines, we can graph quadratics. That would just mean we'd have a slanted asymptote. This just means we would have a quadratic asymptote. And it's just going to approach those values on the end. So it's really not that bad because we know how to graph lines and we know how to graph quadratics. Question for you, can we cross these asymptotes? Yes, horizontal are just end behavioral asymptotes. If they do cross though, they'll just still hug it. Yes. Yeah, but we're going to have to actually go through and divide them all the way, which we know how to do with long and synthetic division. We're going to have to get the actual line, which we'll do in a second. Okay, so let's practice our abilities. We have a vertical asymptotes, which we know will never be crossed because you cannot divide by 0, and that's where they come from, denominator being 0. Horizontal asymptotes are just end behavioral asymptotes, what's happening at the far right and left of your graph. They can be crossed, but they will still hug it. They will not stray away from the asymptote. So let's just practice. Honestly, guys, if you can do this part, the graphing part comes easy after this. This is the hard part of the lesson, being able to determine the asymptotes. So here we go. Let's just practice. All right, so looking at this, my vertical asymptotes come from denominator being 0. So I would have two vertical asymptotes here. X equals -2 would be a vertical asymptote, and x equals 3 would be a vertical asymptote. Questions on that? Okay, then from there you'd say, what's my horizontal asymptote? You'd say it's one of the 3 rules. Now you have to have it, it's usually better to have it in standard form. So on top we have x, and on bottom we have x squared, don't we? Our leading terms, the degree on top is smaller than the degree on bottom, so our horizontal asymptote will be at y equals 0. Good. Now guess what? If you forgot this rule on the test, you could go plug in 1,000. And if you plug in 1,000, you're going to say, oh, it's 0.00002. Oh, it looks like it's approaching 0. Does that kind of make sense? Even if you forgot, you could plug in a really big number and see what's happening. All right, so let's move on to this one. Now in this one, usually guys, to find vertical asymptotes, it's best to have it all factored. So I'm going to factor out a 3. Left is x squared minus 1. So this quadratic factors to be x plus 1, x minus 1. I'm not going to go through that because hopefully at this point we're going to be fine factoring by ourselves. So then from here, this 3 does not have a variable, so that's not going to affect anything. For vertical asymptotes, that is. So we have a vertical asymptote at x equals -1, because we can't be -1. And we have a vertical asymptote at x equals 1. Now our horizontal asymptotes are easiest to find in standard form, which it is already up here. So degree on top and bottom are the same. Therefore, those would divide out perfectly, wouldn't they? So that would be 1/3. So y equals 1/3 would be our horizontal asymptote. Okay, right here, my vertical asymptote is at x equals 3. Now in this one, we're actually going to get, the first time I'm going to go through and show you how to get your official oblique asymptote. Now here's the thing, guys. To do this part, it's easiest to divide if things are in standard form. So I've got to actually distribute this. So that's x squared. Then I have a plus 2x minus x. So that's plus x minus 2. And we're dividing by x minus 3. Because the degree on top and bottom, the top one is larger than bottom, we would divide and get an x. So it's going to be a linear asymptote. So x, but we got to actually divide it. So let's go off to the side. Now, would you prefer longer synthetic division? We got to get the actual answer here. Synthetic. Now we can only use synthetic because this is linear and 1 in front. So yeah, we would use 3. We would do synthetic division. 1, 1, -2. Add straight down, multiply up. Add straight down, multiply up. Add straight down. So we just got the line y equals x plus 4, correct?
It's 12.
What do you mean? Oh, 15. Sorry, 5 times 3 is 15? No. Oh, what am I doing? 4 times 3 is 12. I see. 4 times 3 is 12. Add straight down, we get 10. Awesome. Okay. So we have x plus 4, and then don't we write our remainder as plus 10 when we divided by x minus 3? Now remember, by definition, this is what's happening on the horizon. So let's think for a second. If I was to go right here and plug in 1,000, we're going to have 1,000 plus 4, great. And then we have plus 10 divided by 1,000 minus 3. 10 divided by 1,000 is pretty much 0. So in the end behavior, because this is end behavior, the remainder will not matter. It will not affect your graph enough to make a difference. So we just ignore the remainder. So our horizontal asymptote is actually a slanted asymptote at x plus 4. So that wouldn't throw us off, guys. We would just then go and plot, we would draw in x plus 4. We would have a slanted asymptote. So we know how to graph a line. So yes, the remainder will not matter for this type of, if we're doing asymptotes, that is. Okay, let's actually start practicing graphing these. Here are the steps you're going to take. You don't have time to write these down, so just take a picture, or you'll just have to have me come back to it at the end. But you're going to see me practice these steps every time. So steps to graphing a rational function, this is what I found to be the best. First, you need to factor the numerator and denominator. Second, find the vertical asymptotes, which come from the denominator being 0. It will never cross this. Third, find the horizontal or oblique asymptotes. Remember your 3 different rules. And remember, this is end behavior, so it can cross. And we have the 3 rules, which we just learned right there. Then our 4th step is to just plot some points. Now, we are going to plot certain points. We're going to find x and y intercepts. And then from there, we're going to see what our graph looks like. And if we need to plot more points, we can. Here's what you need to make sure you do. You're going to make sure there are enough points plotted on both sides of your vertical asymptote. So each piece of the graph, you should make sure that you've plotted enough points that you can draw an accurate graph. Let's just start practicing. So you can write this down, and then, you can take notes going through my steps with me. So everybody have a calculator out ready to help. I have a lot of examples. You're going to want to see them. They're actually not bad, as you're going to see when we start graphing these. Okay, first step, back to the top, back to the bottom. That's done. Second step is to find your vertical asymptotes, which are what make the denominator 0. So x equals 3 is my vertical asymptote. I go to the graph and draw in a vertical asymptote at 3. Questions yet? Moving on. So now you're going to do your horizontal asymptote, which is the 3 rules. The degree on top is smaller than the degree on bottom, so our horizontal asymptote is that y equals 0. Guys, 2 divided by 1,000. 0, pretty much, right, everyone? So it's an end behavioral asymptote. So I go to my horizon and draw in an asymptote at 0, at y equals 0. Okay, next thing is to, literally from there, we're just going to plot points. But I need you to plot x and y intercepts, and then you can plot more points if necessary. So we're going to do x-intercepts and y-intercepts. Guys, x-intercepts are when y equals 0. Y-intercepts are when x equals 0. So these are just going to be some x, y points on our graph. Our x-intercepts are when y equals 0, so let's plug that in. So we would have 0 equals 2 over x minus 3, and now we're going to solve for x. Get x alone. So what don't we times up by x minus 3? What's 0 times x minus 3? So we have 0 equals 2. Now, we can't solve for x, can we? The x went away in this one. Therefore, there are no x-intercepts, because we can't solve, so none. Now, that makes sense, because look at our horizontal asymptote. Isn't it on the x-axis? But remember, that doesn't necessarily mean there won't be x-intercepts. But it does make sense, but couldn't there still be x-intercepts? Yes, because remember, they can cross horizontal asymptotes. But even if it was to cross, it would still hug it. Does that kind of make sense, everybody? In this one, it didn't have any. Okay, moving on to y-intercepts. So y-intercepts are when x equals 0. So you'd plug in 0. So you would say, all right, I have an x-y chart here. I'm plugging in 0 for x, and what do I get out? -2/3. Okay, so let's plot that point. That's the first point on our graph. Over 0, down 2/3. So that's like down just a teeny bit, like right there. Now, once you get good at this, you're going to be able to graph this side of the asymptote. But let's say at this point you didn't know what to do. Let's plot some more points, like maybe plug in a 2. So let's plug in 2. So we have 2 over 2 minus 3. So don't we get -2? 2 -2 is another point on the graph. Over 2, down 1, 2. Now guys, I have plenty of points on the left side of the asymptote to graph. Won't by definition it stay close to the asymptotes. So do you guys see how it's coming down? Well, it must be going by that asymptote. Will it ever cross that? Nope. Now we know there wasn't any x-intercepts, so it's obviously coming up and it's approaching this asymptote, right? It's not going to cross it in this one. Okay, now here's the thing, guys. You have to plot points on all sides. Now we know our domain is everything except 3. So do you guys see we need to keep going? There's graph over here. So we would say, well, let's plot another point. Like let's plug in 4 and plug in 5. Everybody, somebody do 4, somebody do 5. So 4 is 2. 5 is 1. Okay, so we're going over 4 up 2 units. over 5 up 1 unit. And now I have plenty of points to see what's going on. Do you agree? They approach asymptote. That's what these graphs do. So we can see it's coming up by this asymptote, and it's coming down on the horizon and approaching that asymptote. So really not that bad, as long as you can follow those steps. Let's do another one. Okay. Once again, please everyone help me out so we can keep going quick. You guys are doing good though. Okay, so first step, back to the top, back to the bottom. Done. Second step is to find your vertical asymptote. Our vertical asymptotes come from denominator being 0. X equals -2 would be my vertical asymptote. Now you find your horizontal asymptote. You have your 3 rules. Degree on top and bottom are both 1. Therefore, you divide your leading coefficients. So y equals 3. So I go up and draw my horizontal asymptote at 3. Now from there, we find points. X and y intercepts. X intercepts. Y intercepts. Okay, x intercepts are when y equals 0. So I have 0 equals 3x plus 5 divided by x plus 2. So solve for x. Wouldn't we times up by x plus 2? Now think about it. This is always going to be the steps we take. We're going to set it equal to 0 and we're going to times up by the denominator every time. So what's really going to matter? The numerator. Won't 0 times the denominator every single time become 0? So all you have to do for x-intercepts is solve the numerator. So we have 0 equals 3x plus 5, so then solve for x. Minus 5, divide by 3. So x is equal to -5/3. So we have the point -5/3, comma 0. That's our x-intercept. -5/3 is -1 point something. So I'm going -1 and a little bit. That's the x-axis. Now let's keep going. Y-intercepts are when x equals 0. So we're going to have 0, comma, plug it in. 3 times 0 is 0, plus 5, and then divided by 0 plus 2. So won't it be 5/2? Which is 2 point something, right? 2.5? So let's go over 0 up 1, 2.5. Now, that is enough points on the right side, do you agree? To graph, because by definition, it's going to approach the asymptotes, so it must be coming up and approaching. Now, let's say you didn't know that, then plot some more points over here. If it crossed, would you freak out? No, because if it crossed, it might cross right here, but it will just hug it. Everybody good? Okay. Now, we're missing stuff. You have to plot points on all sides of the graph. We know our domain is everything except -2. We don't have any graph over here. We need some. So now you would just make an XY chart and plot a couple points. Like, let's plug in -3. And we can plug in -4 if we so desire. So everybody plug those in, calculate them for me real quick. Pick one, go. Yes. It's 3 points. These points? Or is that what you're asking me?
Oh no, I know how you got those asking me questions.
Well, these were the 2 points we had, and so like these will always approach asymptote, so we just connected them through. -3 is 4. Okay, awesome. -3 is 4. Now, guys, once we get really good at this, we'd be able to stop right there and graph it because we know for a fact it's not going to cross the x-axis again, or else we would have found it, right? And it's going to approach the asymptote up here, and it's going to approach the asymptote down here. Everybody good? Next one. Okay, let's go again. First step, everybody, help me out here. We're going to factor the top, factor the bottom, if possible. So if we look at the top here, if we factor it, will multiply to be 10 and adds up to be -4, nothing. So it doesn't factor, so we'll not factor that. The bottom will multiply to be 1, adds up to be -2, 1 times 1, negative. So the bottom factors to be x minus 1 times x minus 1. Okay, now we can find our vertical asymptotes. X equals 1 is my vertical asymptote. It happened twice, so that's asymptote on top of an asymptote. It's just the one asymptote, you know? Okay, let's find our horizontal asymptote. You would use your rule. Isn't the degree the same on top and bottom? So y equals 2 would be my horizontal asymptote. So then from there, you're going to find x and y intercepts. So, and something interesting happens on this one. That's why I put it on here. X-intercepts. So we know that that's when y equals 0. So 0 equals, and then we know when we take this and times up, the denominator is not going to matter for x-intercepts, just the numerator. So we have 2x squared minus 4x plus 5. We just saw that it didn't factor, therefore we have to use quadratic formula. Now just because we have to use quadratic formula doesn't mean it doesn't cross. But if it's imaginary, it doesn't cross. If not, it's just a decimal. So we'd say x equals negative b, 4 plus or minus the square root of b squared. So negative 4 squared minus 4 times a times c all over 2 times a. So we have 4 plus or minus the square root. This is 16 minus 40. You guys see how we have a negative number under my square root? Therefore, we have no x-intercepts. So none again. Now when I first saw that, I'm like, well, we've messed up last hour. But no, that's not necessarily true. Let's keep going with it. So then y-intercept is when x equals 0. So if I plug in 0, I'm going to get, that's a point, 0, 5, aren't I? So here's a point, over 0, up 5. Okay. Well, I know now for a fact I could plot more points if I really wanted. And I think most of you probably would. So do you guys feel confident drawing in the graph on this side now at this point? With just 1 point? I do. Because we know it's going to approach that asymptote, and it's going to approach this asymptote. We're doing rough sketches. It doesn't have to be perfect. Now, I don't have anything on this side of the graph, so let's plug in a 2. So everybody, calculate that for me, please. What do we get? We got 2 5. So look, over 2, up 5 units. Great. Well, then we can see what's happening now, because it's approaching our asymptote. And it's approaching our asymptote. You guys see how it really doesn't have any x-intercepts? And it all worked out. Okay. Great. Couple more examples. Stick with me here. Let's see. Okay, I think we're probably good with something with the same degree. Okay, let's do this one. Okay, so we would say, okay, factor the top, factor the bottom. The top doesn't factor, so the bottom factors to be x plus 5, x plus 5. So our vertical asymptotes come from x equals negative 5. Agreed? So we would draw that in. Then you would say, okay, my next step is to do my horizontal asymptote. What is it at? 0. The degree on top is smaller than the degree on bottom. Y equals 0. Okay, now from there, x-intercept. X-intercept is when y equals 0, so 0 equals 5x plus 21. I times that up. I times this up to 0, and it's gone. That's why we just solved with the numerator. So subtract 21, divide by 5. What decimal is that? So we have the point negative 4.2 comma 0. Agreed? So look. It's crossing the x-axis at negative 4.2. Now, it's on the asymptote. Should we freak out? No, it's on a horizontal asymptote. Everything's good here. Okay, moving on to my, that was the x-intercept, y-intercept. So when x equals 0, if I plug in 0, I get 21 over 25. 0.84. So we're going over 0, up 0.84. No, wait. That's fine. Over 0, up 0.84. Okay? Interesting. And we did this correct, right? Okay. Okay, cool. There's a good reason I did this one then. Okay, so then from there, we're going to plot some more xy points. Now here's the thing, guys. We don't have anything on this side of the graph, agreed? So let's plug in negative 6. That'll be enough for us to go with. get negative 35.25. Okay, so negative 6 down, clear down here. So don't we know it's in this section? Since it's down, clear down here. So it's approaching this asymptote and coming up. Would it cross? No. Isn't it only crossing there? Wasn't that our x-intercept? So what's happening here? Well, to me, it's coming in like this, isn't it? And it's coming down. So it's not going to go back up. It's going to keep with the same, and it's just going to follow the asymptote. It's going to keep with the same direction. Cool. And keep going down. Yes. Awesome. But once again, we could keep plotting some points, and you're going to see that it will still hug that asymptote. Okay, let's do one where we have a slanted asymptote. Agreed? Okay. We haven't done one with 2 vertical asymptotes. Do you want to hurry and do one with 2 vertical asymptotes? It's probably a good idea. Okay, sorry, there are a lot of examples today, but it's because you can see so many different things, and I want you to feel comfortable when you get to the homework. Okay, so first things first, factor the top, factor the bottom. This one's a really good one to do, actually. So if you factor the top, what multiplies to be negative 4 adds up to be negative 3. 1 times 4, negative 4. The top factors to be x plus 1 and x minus 4. Okay, on bottom, what would we pull out? 2x, and left would be x plus 2. Okay, awesome. Vertical asymptotes come from the denominator being 0. So x equals 0 and x equals negative 2. Agreed? So I'm going to go to 0. I'm going to go to negative 2. Okay, moving on to horizontal asymptotes. It's better to do it in standard form. Degree 2, degree 2, so 1/2. Y equals 1/2. Leading coefficient, so... Okay, from there, x and y intercepts. X-intercept. X-intercepts are when y equals 0, so 0 is equal to x plus 1 and x minus 4. We only need the numerator, don't we? So x equals negative 1 and x equals 4. It is crossing at negative 1 and 4. So it's crossing at negative 1 and it's crossing at 4. That's not enough points to continue graphing. Let's do y-intercepts. So y-intercepts are when x equals 0. Uh-oh. Are there any y-intercepts? Wasn't that a vertical asymptote? Will it ever cross a vertical asymptote? No, so none. So now from here, guys, let's plot plenty of points. Everybody grab a calculator. So let's think about it. We obviously need something on this side of the vertical asymptote. So somebody plug in negative 3. Yes. Because we're just trying to plot some points, which is we're just calculating from the original function. Meanwhile, somebody, like, I want some more points than just this. So let's have some people plug in maybe 2 and 1. $2.3. Okay. So negative 3 up 1, 2. Well, sorry. Up 1, 2.3. Okay, that's great. Okay, do you guys feel confident filling in this side at least? Yeah, I agree, because we're going to come up by that asymptote, definitely, right? And then we're coming down by this asymptote. That's what asymptotes do. Now we got to plot some, now look, in here where we have graph, but we got to fill it in. What? Yes, so that's my point here. Do you guys see how we don't only have the whole numbers? If you have to plug in decimals, sometimes you do. So let's try plugging in 0.5, and then that might help us. Now somebody else, look, if we plug in 0.5, that'll tell us where to go, either up here or down here, depending. And I would probably also plug in negative 0.5. Because this can go a lot of ways. Look, it can hug that asymptote, it can go up here, because it can cross horizontal. So we need to plot also negative 0.5. So everybody please take a turn, take one of those and go. Did anybody plot 1 or 2 for me? Negative 3? Negative 3/8. Okay. Perfect. So over 1, down 1. Perfect. Well, I can now see, just so you know, like, can you agree that at least on this side of the asymptote we can finish graphing? Because it's coming up, it's only crossing there and then hugging the asymptote. It's going to come down by this asymptote. So now we're just at pause here because we need some more points. So we're plugging in 0.5 and negative 0.5. Oh, at 0.5?
Yes.
Oh, sorry. Negative 2.1.
So then wouldn't that be that it would just be like a flat one and it would just...
It might be.
So what else would it bring down?
It can cross horizontal asymptote. Remember? It doesn't cross the vertical. So 0.5 down 1, 2 and a little bit. So we know for a fact it's coming down like this. But guys, here's the thing. It could circle around or it can actually go up like this. That's the thing. Does that make sense? Because it can cross horizontal. Anyone else? Negative 0.5? Yes.
Wait, so we be on the other side?
So here's 0. I went over 0.5 down 2. And so now I got to do negative 0.5. 1.5. Oh, I like that. Okay, so we're over at 0.5 up 1.5. It actually does circle and go up. Does everyone see? It just depends on the problem. So it's going to hug that asymptote. Okay. Because everybody, just a reminder, really this horizontal asymptote is what's telling us what's happening here and here at the ends. That's why the middle, it's not going to matter for us. Okay, cool. Awesome. Okay, so hopefully we're feeling it. Let's do one slanted one, then I'm going to let you do homework. But I do think you need to see a slanted one. Do you all agree? Agreed. Agreed. Okay, here we go. So back to the top, 1 multiplies to be negative 5, adds up to be negative 4, 1 times 5. Are you guys feeling like freaked out by this, or is it not that bad? Not that bad. Especially if you follow the steps. And guys, once again, you can plot as many points as you want until you feel confident connecting them. You know, I'm not plotting very many, but you can always plot more. So the top factors to be x plus 1 and x minus 5. And then we have over x minus 3. Vertical asymptote is at x equals 3. Horizontal asymptote is better to look at in standard form. Well, we got an oblique asymptote, don't we? Degree on top. So let's do synthetic division, but I can only do that in certain cases, which this is one of those cases. 3, 1, negative 4, negative 5. Add straight down, multiply up, add straight down, multiply up, add straight down. Will the remainder matter? No. Not for this. For asymptotes, no. So y is equal to x minus 1. Now you do have to know how to graph a line. Remember, lines have this form. mx plus b, where b is the y-intercept and m is the slope. My y-intercept is negative 1. Then isn't my slope 1 over 1? Agreed? So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Down 1 over 1. Okay. So now from here, plotting x and y intercepts. X-intercepts are going to be the numerator. So x equals negative 1 and x equals 5. So it's crossing at negative 1 and it's crossing at 5. Okay, that's fine. Y-intercept. Y-intercepts are when x equals 0. So 0, comma 5/3. Negative 5 divided by negative 3. So that's 1 point something. So over 0, up 1 point something. 1.6. Perfect. Now from there, question for you. We need to fill in every piece of, like on every side of the asymptote. Do you guys feel confident filling in this side or not yet? It's up to you guys. We can plot more points. Yeah, let's go ahead and plug in x, y, negative 3 just to make sure and see where things are going. I want you, like over here we need some more points for sure. So I want someone to plot 4 and maybe 6. And then I'm going to talk to you about where we'll go from there. So everyone pick one. I'm waiting on you. Okay, awesome. Okay, let's look at graphing those and then points we might want to graph. So -3 down 2.6. -3 down 1, 2.6. Now I'm feeling dang confident. Do you guys see what's happening? Isn't it approaching the oblique asymptote? So I'm coming and aren't I approaching? Yes. That's what asymptotes do. And I can see the more, you could plot more points if you really wanted. Now we could plug in some more points over here, but it is going to come up by this asymptote. So I'm not necessarily curving it perfectly, but it's going to come up by this. Okay, we have over 4 down 1, 2, 3, 4, 5 units. And then, so obviously it's coming down like this by this asymptote. And then over 6 up 2 okay, so over 6 up 2.3. So now I know it's coming up by this asymptote. Yes. You don't know unless you plot points, but it never crosses the vertical, right? Yeah. It just may or may not. Like but we're doing rough sketches, so it doesn't have to be perfect. You know, it might cross out at 50. We don't really care that much. Does that make sense? Yeah. So let's say you happen to graph 8 and it crossed. You wouldn't like freak out. You would just have it hug it. It would cross, but then it would just stay close to it. Yes. It depends on what point you plot. So if it's within like. If you are following these steps, you're going to have a sufficient graph. Does that make sense? So I haven't necessarily checked to make sure I haven't, you know what I mean? It happens sometimes, it might not, and I'm not. These steps will be all you take. Guys, here's the problem though. We don't have any points plotted in here. There could be graph in here, in here. We obviously know if we plug in 4, we got this, right? So we know on this side we're good. But like, do you guys see what I'm saying? Like we probably should plot a couple points in here to make sure there's not a graph in here, because there might be a graph like this. There might be. So I would plot, so if somebody wouldn't mind plugging in, let's do 1 and 2. 9? So over 2 up 9. Okay, well then we're good, because that's up there. You guys see how I'm just making sure I've filled in the x-axis, everything in the x-axis. Right, yeah, we should be good. I just want to make sure that everybody understands. You need to make sure you've checked all pieces of the graph. Because there are times when like a graph will like go like this inside. But then it would have been like this, if that makes sense. So, okay, awesome. Do you guys feel like you would rather just practice at this point than see more examples? Because really it just comes down to following those steps and rolling with it. Okay, awesome. We'll call it good then. I had like 10 million more examples. I don't know how I expected to do all that. Okay, awesome. Start practicing.